conversations about naval warfare generally revolves around high-end platforms, like destroyers, attack submarines, and aircraft carriers. Yet, as the United States Navy prepares for potential conflicts across the vast Western Pacific, it faces a fundamental problem that advanced warfighting ships cannot solve alone. That problem is amphibious warfare and logistics in contested islands. To solve it, the US Navy is turning to an unexpected low-tech solution, the McClung-class medium landing ship, designated LSM. The operational challenge stems from a major transformation within the United States Marine Corps. The Marine Corps has gradually shifted away from large amphibious landings and has instead refocused on mobile distributed island operations. Small teams of Marines will deploy across remote island chains, operating anti-ship missile launchers and air defense systems behind the enemy line to disrupt shipping and logistics. To make this strategy work, these dispersed Marine units must move constantly and insert onto unprepared shorelines without attracting major enemy attacks. Large amphibious warships are completely ill-suited for this mission. Vessels like the 45,000-ton America-class landing helicopter Assault, the Wasp-class landing helicopter Dock, or the 25,000-ton San Antonio-class amphibious transport dock are enormous capital assets. Risking a really expensive capital ship with a large number of sailors in highly contested waters to insert 100 Marines and a few missile launchers is an unacceptable trade-off. This capability gap created the requirement for a dedicated medium landing ship. To understand where the McClung class fits, it helps to distinguish between a medium landing ship and a classic tank landing ship, commonly referred to as an LST. Historically, an LSM is a beachable, ocean-going vessel designed to transport modest amounts of troops, vehicles, and cargo directly to shore without requiring port infrastructure or specialized landing craft. A tank landing ship performs a similar task but is typically larger, featuring a reinforced hull and a special bow ramp designed to drive heavy combat vehicles directly onto a beachhead. Although the US Navy classifies the new McClung class as a medium landing ship, the vessel design is directly derived from a tank landing ship blueprint. As a result, the McClung class brings classic LST capabilities back into the fleet, despite its official LSM designation. It is basically an LST. It provides a direct shore-to-shore delivery platform that bridges the gap between small landing craft and giant amphibious transport. The development path of the McClung class reflects a rare triumph of defense acquisition discipline. The program originally began in 2020 under the label Light Amphibious Warship. Early concepts and initial defense industry proposals quickly ran into trouble. Industry designs began adding complex military features, combat systems, and specialized survivability requirements. These additions caused cost projections to surge, threatening to kill the program before construction ever started. Recognizing that cost growth would ruin the entire concept of a high-quantity fleet, the US Navy pivoted hard in 2024. The service abandoned custom designs in favor of an off-the-shelf commercial design. In late 2025, Naval Sea Systems Command selected the Landing Ship Transport 100 design from the Dutch shipbuilder Damen Group as the foundation for the new class. The US Navy purchased the complete technical data package for $3.3 million, giving American shipbuilders a proven blueprint to build domestically. The Navy currently plans to construct between 18 and 35 ships of the McClung class medium landing ship. Construction of the lead vessel was awarded to Bollinger Shipyards in Pascagoula, Mississippi. In terms of physical characteristics, the McClung class is intentionally modest. The ship has a full load displacement of approximately 4,000 tons, an overall length of 100 meters, and a beam of 16 meters. Its most critical dimension is a shallow draft, which measures just 3.5 meters. This shallow draft allows the vessel to navigate island waterways, cross shallow reefs, and beach itself directly on flat shorelines where vessels with deeper draft cannot operate. The ship is powered by standard commercial diesel engines driving 2 propellers. It reaches a top speed of 15 knots. While 15 knots is modest compared to the 30 knots of large surface combatants, high speed was intentionally traded away to save weight, volume, and fuel. Cruising at economical speeds gives the McClung class an impressive unfueled operational range of 6,300 kilometers. This endurance allows the vessel to cross vast stretches of the Pacific Ocean without issue. Efficiency extends to staffing as well. The McClung class requires a core US Navy crew of only 18 to 32 sailors. Compared to the hundreds of crew members needed to operate an amphibious transport dock, this ultra-lean crew structure drastically reduces operating expenses and minimizes manpower burdens across the fleet. A visual walkthrough of the ship from bow to stern highlights a utilitarian focus. At the bow, the ship features heavy bow doors and an internal folding ramp. When approaching an unprepared shore, the bow doors open outward and the heavy ramp extends forward onto the beachhead, allowing vehicles and troops to roll directly off the vessel onto land. The hull near the bow is reinforced to sustain repeated beaching impacts on sand, gravel, and coral. Moving inward, the bow ramp opens directly onto a long vehicle deck that runs through the interior of the hull. This drive-through deck layout simplifies loading and unloading, eliminating the need for complex vehicle maneuvering inside the ship. Above the main deck sits a compact, blocky superstructure. The superstructure houses the ship's navigation bridge, living quarters for the ship's company, and simple dining facilities. The sensor suite atop the mast relies primarily on commercial navigation radars, basic surface search radars, and standard military communication gear. Defensive armament is minimal, consisting of a single 30mm remote weapon system and several heavy machine guns. At the stern, the ship features an additional stern ramp, allowing for roll-on, roll-off loading from commercial piers or larger auxiliary ships. At the aft sits a flight deck for supporting medium helicopters and vertical takeoff uncrewed aerial vehicles. The flight deck provides crucial aerial resupply, medical evacuation, and reconnaissance capabilities without taking up precious vehicle storage on the main deck. Despite its modest dimensions, the carrying capacity of the McClung class matches the requirements of mobile marine platoons. The vessel provides permanent facilities for 250 to 282 embarked Marines. In addition to personnel, the ship offers over 500 tons of cargo capacity. This payload space can accommodate a mix of heavy vehicles, light tactical vehicles, logistics trucks, ammunition, fuel containers, and mobile missile launchers armed with, for example, the Naval Strike Missile. Beyond its physical design, the true advantage of the McClung class lies in how it avoids the massive industrial bottlenecks currently affecting American naval shipbuilding. Right now, major Tier 1 military shipyards in the United States, such as General Dynamics Electric Boat, Huntington Ingalls Industries, and Newport News Shipbuilding, are severely congested. These yards face long backlogs of nuclear submarines like the Virginia-class attack submarines and the Columbia-class ballistic missile submarines, as well as the Gerald R. Ford-class aircraft carriers and Arleigh Burke destroyers. adding another warship construction program to Tier 1 shipyards would result in even more severe delays and massive cost overruns. The McClung class completely bypasses this industrial bottleneck. By relying on commercial standards for the less critical components of the ship, the US Navy can distribute construction across mid-tier, Tier 2 commercial shipyards. Facilities like the Bollinger Shipyard in Mississippi possesses the exact commercial expertise in dock space needed to build 100-meter steel hull vessels rapidly. This approach enables the Tier 1 shipyards to focus on high-end naval vessels. To manage this dispersion of shipbuilding efforts, the Navy adopted a vessel construction manager model. Under this approach, a single commercial entity coordinates engineering, material procurement, and scheduling across multiple regional shipyards. This allows the US Navy to build multiple landing ships simultaneously in different parts of the country. Leveraging an off-the-shelf design like the Daman LST-100 also eliminates technical design risk. Design failures, engineering redesigns, and software integration delays often double the cost of new naval ship classes. Because the LST-100 design has already been built and operated internationally, the core naval architecture, structural layout, and mechanical integration are already proven. The US Navy did not have to pay billions of dollars in research and development. Using off-the-shelf commercial diesel engines and generators means replacement parts can be sourced through worldwide commercial supply chains, keeping maintenance simple and inexpensive. This commercial approach keeps procurement cost very low. The US Navy targets a unit cost of $150 million to $250 million per ship for the McClung class. To put that number into perspective, a single San Antonio class amphibious transport dock cost around $2 billion. An America class amphibious assault ship cost nearly $4 billion. For the price of a single large amphibious assault ship, the Navy can acquire 10 to 20 McClung class landing ships. This dramatic cost difference changes the equation of naval attrition. In a high-intensity war against a peer adversary with capable anti-ship ballistic missiles, cruise missiles, and a large submarine fleet, naval losses are inevitable. If an enemy missile or torpedo sinks a $4 billion capital ship carrying 2,000 Marines and dozens of aircraft, it represents a catastrophic loss that severely degrades naval capability. Conversely, the McClung class provides high attrition tolerance. The opponent cannot easily track around 30 small vessels hiding among civilian maritime traffic and large numbers of islands. Even if the opponent successfully targets and sinks one McClung class ship, the loss represents a small fraction of the amphibious landing force, and the vessel can be replaced as a fraction of the cost and time of a major warship. The McClung class medium landing ship is not a glamorous warship. It lacks missiles, large guns, and radar-evading stealth design. Yet, in modern naval warfare, utility often matters far more than complexity. By pairing proven off-the-shelf designs with flexible operational doctrine, the US Navy has created a practical asset tailored for island warfare. Affordable, simple, and dispersed, the McClung class may well prove to be the low-tech trump card for the US Navy and US Marines.